Hello, students. So, students, today there's one more concept related to the capacitor and electric current. And this concept is also very important concept. It's very important concept from the JEE Main, JEE Advanced, and even from the NEET point of view, because the concept is good, but the calculations are not much difficult, neither they are lengthy. So, watch the question and solution. The question is that there is a capacitor having square plates of side A into A. The capacitor having square plates having side A into A, and there is a dielectric constant K. Separation between the plates is D. It is connected to a battery of voltage V. Now dielectric is being carried inside the capacitor. Dielectric is being carried inside the capacitor with a velocity V. So you have to calculate the leakage current in the circuit. So students, first of all, see what is the meaning of leakage current. You see, leakage current is what? Because voltage is fixed. So the charge on the capacitor C, the charge on the capacitor Q will be equal to what? CV. Voltage V is constant. So as the more and more dielectric will come inside the capacitor, its capacity will increase. That means at a certain rate, the charge of the system will increase as the capacity will increase. Is that clear? At the rate at which capacity will be increasing, at the same rate charge Q will be increasing, at the same rate multiplied with the V, the charge on the capacitor will be increasing. So if the charge on the capacitor increases, that means more charge flows from the battery towards the capacitor. And that will be called what? Current. So current caused in this way is called leakage current. Let's see, suppose at a point of time, the x length of the dielectric is inside the capacitor. So remaining length is what? A minus x. So the capacity of this capacitor becomes C equals to A x epsilon naught into K upon D. It is the capacity of that part in which dielectric is present. And the capacity of this part where dielectric is not present is what? A into A minus x into epsilon naught upon D. So see, both the parts are in parallel because one plate of these two capsules are connected together and one plate of these two is also connected together. So they are in parallel. So the total capacity C becomes A x epsilon naught K by D plus A into A minus x into epsilon naught by D. This is the total capacity of the system, right? So you see, the charge Q on the system will be C into V. The charge Q on the system will be what? C into V. So charge Q becomes A epsilon naught upon D is common, V is also common. This becomes K into X plus A minus X. This is the charge Q. Now see at what rate this charge will vary. The charge will vary at a rate dQ by dt. That we call the leakage current, and that equal to A epsilon naught into V upon D. Kx derivative will be, because we are differentiating with respect to time. So K dx by dt. Dx by dt will be what? It will be the velocity of the dielectric. X is the distance inside it. So at what rate you will carry inside it, that will be dx by dt. That is the velocity of the dielectric. So Kv plus derivative of A will be 0 minus V. So the leakage current I becomes equal to A epsilon into V upon D into here small v. The velocity will also be common. Velocity will also be common into what? K minus 1 is the leakage current. So basically the concept of leakage current was what? Generally in such questions, they'll keep what? They'll keep the voltage constant. They'll keep the voltage constant. While they're keeping the voltage constant, they'll bring some change to the capsule, and because of that, capacity will change, so the charge will change, and if what rate charge will change, that will be called the leakage current in the circuit. I'll give you one more example. You'll see. Look at this. So this is the example that you'll see. Here's also the similar example. Here what we are doing, both the plates of the capsule are being brought closer to each other with a velocity v. Now what will be the leakage current? Again you see, as the plates will be brought closer to each other, the capacity will increase, voltage is constant, so the charge on it will increase. Obviously, the rate at which charge will increase will be called leakage current. So suppose at any point of time, the separation is x. So the charge Q will be CV, Q equals to C A epsilon naught upon x into V. There is a charge Q A epsilon naught upon x into V. So dq by dt will be equal to A epsilon naught into V, and derivative of 1 by x will be equal to what? Minus of 1 by x squared into dx by dt. So with the derivative of what? 1 by x. So dq by dt is a leakage current I equals to minus a epsilon naught into voltage v. Dx by dt is the velocity v upon x squared. Now see, x will vary at what rate? 2v. X will vary because of what? Velocity of both the blocks. So dx by dt will be what? Relative velocity between the two blocks. Dx by dt will be what? Relative velocity between the two blocks. So there's the current I. Now you have to calculate the current at the moment when separation was D. So you write what? Current I equals to A epsilon naught into V into 2V divided by what? D. Minus sign is indicating what? As the separation decreases, capacity increases. So you need not to worry about that. Forget that minus sign. You need to calculate the current I. So this will be the leakage current. So I hope this concept got clear, that they'll keep the voltage fixed. They'll bring some changes in the capsule. Due to that changes, capacity will change. So the charge on it will also change. And at the rate the charge will be changed on the capsule will be the leakage current. So I hope students this concept got clear. And in my next video, I'll take one question in which voltage will not be kept fixed. Voltage will not be kept fixed, and there'll be some current in the capacitor. So uh, watch this carefully, understand, and so that the next concept will also be very clear to you. All right.